Miss Ann here. Today we are talking about building structures. And very fortunately, I have a colleague, Neil, who majored in engineering at UL Lafayette. And so he is going to be with us to give us some advice about an experiment that I attempted to run earlier. I successfully ran it, but it may not come out the way I wanted it to come. But before we get into that, Shaun, take a moment to tell us about yourself.
Well, I'm originally from Canada. I've been down here in Louisiana now just over 20 years, so it's home for me now. I played minor league hockey for a bunch of years, and then when I
Wow.
finished up, yeah, then when I finished up, I was going to school here in Lafayette, and when I graduated in engineering, fortunately, CGI was at the career fair when I was there, and they decided to take a chance on me.
All right. Well, great. Well, we're so glad that we did and that we have you with us. So, what do you do at CGI?
So for the 4.5 years I've been there, I've been a business analyst. So more or less the intermediary kind of between the developers and the customer.
Mm-hmm.
So been in a couple different projects where I just kind of help out with testing and making sure everything gets back to the customer in the shape they want it.
All right. Well, and is that something that requires an engineering degree?
The engineering really doesn't come into my job other than the ability to, critically think. And that's a big part of engineering, being able to try and think outside the box and solve a problem that otherwise isn't as simple as it sounds.
Hmm. So you don't have to be an engineer to do your job, but the fact you have that engineering background is helpful on the critical thinking skills.
Absolutely right.
Okay.
Yeah, there's a lot of us within the company that are in the same position that have a lot of different backgrounds from university.
All right. Well, great. And
Yeah.
so you majored in engineering. Now, is that just like one degree, or are there different types of engineers? Tell us about that.
Okay, so there's a few different kinds. I mean, civil and petroleum is very common around this area, but when I was going to university, I really didn't know what I wanted to do when I grew up, so I chose the most broad, which is mechanical. It's more of the design and analysis. So yeah, I figured I'd go with the most safest, in my opinion. So
So you mentioned that a lot of people in this area, a lot of your peers majored in petroleum engineering. Let's say someone's watching this in Pittsburgh, Pennsylvania. Can you help explain to them why so many people here would major in petroleum engineering?
yeah, I mean the oil industry has been a big part of the Lafayette community for as long as I've been here and many years before that. So I think that's the route a lot of kids and adults when they go to school. That's usually a pretty safe route for them.
All right. Well, and so, Sean, let me tell you a little bit about the lesson that I've been working on and get some advice from you on it. So, so of course, we have the STEM program, and the E is for engineering. And the last week or this week, we're actually working on a lesson called building structures. And so, what we wanted to do was to build like a frame of a building and see if it would get blown over by a fan. And so I want you to watch the video that I'm about to play to show you how the experiment went. And then afterwards, I'm going to ask you a couple questions about it.
Sure.
So, you ready?
Yes.
Okay. All right. Let's see.
Good day, Miss Ann here, and today we're going to be talking about building structures, engineering specifically. And so we had a lesson that I went through and I made a building and or a frame of a building at least. I made mine out of paper straws. You could use paper straws, you could use popsicle sticks, you could use many other things, but this is how I made mine. And what I did here, I did the frame, I did a little facade, and the test is going to be how well does this structure stand up. So I'm going to test it by putting a fan on it, kind of simulating a hurricane or a windstorm, and we're going to see, does it fall apart, does it blow away, what happens to this building when it's put under pressure. So let's test it out. One, two, oh no! you see that my building only lasted about 2 seconds before it started blowing away. I definitely want the building to last longer than that. I very fortunately have a colleague named Shaun, and he graduated in engineering. And so he told me he would take a little time with me today to talk over how my building structure experiment went and give me advice on how to make it better. Thanks so much and stay tuned.
Okay, so as you can see from that, I built my structure. I put it to the test of the fan, and it failed, I would say, kind of miserably. I mean, the only thing I think that would have made it more miserable would have been if it completely would have collapsed. But yeah, and so it lasted 2 seconds. Don't think that is what I would define as success. So Shaun, I wanted to get your take on how that experiment went, why it blew off like it did, and what advice would you have to make the structure more stable?
Yeah, so from watching the video, I guess what I would say is that obviously the force of the fan pushing it to the side was strong enough to counteract whatever the weight is of the building. So if it's a model, you can deal with that. But I guess initially either putting some kind of weight on near the bottom part of the base. But I think the biggest thing is reducing the surface area of the actual building. You would have to make it obviously a smaller building, because the higher the building and the wider, the more surface area gets taken by the wind, right? So that could be initial thing. And then I guess to go along kind of with adding weight, you wouldn't have to put as much weight if you had something on the bottom to create friction, right? So to keep it from sliding away, which would be another alternative. And maybe a little bit of all of that would reduce how much you had to actually make it smaller in surface area, right? If you added a little bit of weight and a little bit of friction to counteract that force coming in, the lateral force coming in.
And so tell me, what is friction?
So friction, it's kind of in easy to explain terms, just something that resists an object moving, right?
Mm-hmm.
So if you want it to be on a slip and slide, you put some kind of soap or grease or something to take away the friction effect, right? So you want the opposite when you don't want something to move if it's not anchored down. So if you think of like sandpaper on wood, you know, it's hard to move if you push relatively easy, but the harder you push, you're going to be able to push through sooner or later. So you want to find that balance of cost and materials to have enough to keep it from moving, but not too much.
Well, you know that, Shaun, that gives me an idea. So I had my building on the plank floor, so it's like a ceramic plank
Right.
floor. What if I put it on carpet?
Yeah, that would definitely be less or more friction for the building structure for sure.
Okay, all right. So
And
okay, so we have some ideas. So we have put it on carpet is one.
yes.
Then we have an idea of put a weight in it or on it. And do you have any suggestions for that?
I would say maybe evenly distributed along that front
Okay.
edge, or on both corners to try and make sure it's even on both sides. Because that would
Okay.
affect it too. If you have more weight on one side, it would obviously maybe push the other side and cause it to
Okay.
twist. Right. Yeah.
All right. And then another thing you had said was to reduce the surface area. Now, would that require me basically making a new building or taking that one apart and making it different?
Right. And that's why I'm saying if you can find a balance of all these things where maybe you don't have to cut it all the way in half, if you have something to cause friction and a little bit heavier weight.
Okay, gotcha.
So it's just a mixture of different options. You could try cutting a little bit off and put a little bit of weight and see. So I guess that's what experiments are all about, is finding the balance the best you can of what your product you want to look like.
And you know, it's interesting you say that, because when I started this conversation, I said my experiment failed. Would you have defined that experiment as a failure?
No, I think that's what experiments are. You come up with a hypothesis or an idea, and you work towards it, and you you make mistakes and you learn from it and you make adjustments. And I want to say there's that saying about Ben Franklin made.
Yeah.
So he found 999 ways not to make a light bulb.
Right. Yeah, that is a great point. That Ben Franklin quote is definitely one of my favorites when I'm trying out new things like this. What I'll do next is I'll do a series of experiments. We'll try not to look at them as failed experiments, but ways that I'm learning. And the first thing I'm going to try is putting it on carpet. Then I'm going to try putting it on carpet with a weight.
Yeah.
Then I'm going to try, if those don't work, so our next thing is reducing the surface. So if the carpet and the weight doesn't work, like, am I just, is that building done for, or?
No, what you could do is maybe try cutting like halfway up,
Okay.
so that air could go through it.
Okay.
Just
cut
anything.
The straws all the way across?
No, you don't have to cut the straws. Just maybe
cut the facade. Okay.
Yeah.
Okay. And would a roof help?
Well, I guess if it did it like the overhang, I guess I really didn't talk about that. But if you had that little bit of eaves, maybe that kind of came out a few inches or something.
Okay.
I don't know if it'll work, but.
And I think was that the design where you put like 2 additional straws in the front?
Yes.
Make a V and go down a little bit.
But you don't have to make a V. Try and make it like a rectangle down, not a.
Rectangle. Oh, okay, like an awning.
You know what I mean? So it's the whole length of the.
Okay. Yeah, I can make an awning. I like awnings a whole lot, so that works for me.
So we'll see if it works.
Okay. Well, thank you so much for this, Shaun. This was very helpful. I'm gonna test those ideas out and regroup with you tomorrow, I believe, and then we'll see how they work.
Awesome.
All right. Thanks. Have a great day.
You too.
Bye-bye. Hey, Shaun. It's great to have you back today.
Hey, Ann. Thanks for having me on again.
All right. Well, I cannot wait to show you how our experiments went. So let's roll that video.
And we're back with experiment 2. So, like Shaun advised, I put a rug down to create friction for this structure. So we're going to see if this keeps it from blowing away. Turning on the fan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So experiment 2 went fantastic. The house did not blow away, although clearly the wind was putting some pressure on it. However, our carpet here did blow up in the front. And so what we're doing for experiment 3, we're putting down some rocks and seeing if that helps. And is this going to make our house more or less likely to blow over, or perhaps the same? Let's give it another spin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Once again, we have made it to 20 seconds. Although the only thing I've noticed is even though our building structure didn't blow over, it seems to have bent a little bit. And so when I talk to Shaun this afternoon, tell him about how this experiment went, we're going to find out how we might be able to reinforce these joints to make in our building to make it stronger. Thanks so much, and see you in a few. Back for experiment 4. So for the first 3 experiments, we put our fan here on the lowest setting. Let's think of it as a tropical storm setting. And the first time we had no carpet, It blew all the way back up against the door in about 2 seconds, or at least started blowing in about 2 seconds. And the second two experiments, the house lasted about 20 seconds on our carpet here and did not blow over. We just decided to call it at that point. So now what we're going to do, we're going to put a hurricane on it and put the setting up. We'll say this is what, maybe a category 1 hurricane, put it up to the mid setting on our fan here. Let's see how it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're going to give it a few more seconds. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. It kind of reminded me of the 3 little pigs where he said, I will huff and puff and blow your house down. It did not blow down, but it sure is getting closer to it. So it didn't look like it was going to fly backwards, but it sure did look like it was putting a lot of pressure. So that was our category 1 hurricane. We're going to go up to a category 3 and put on the next setting and see if our house survives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So you might have noticed after about 1 or 2 seconds, our house backed up a little bit. The friction worked though. It didn't go back any further, but it is continuing to get weaker and weaker on the joints.
All right. So Shaun, after viewing the video, what feedback do you have?
Well, it appears the friction helped out quite a good amount there. It wasn't sliding like it did in the previous video from yesterday.
Yeah, I was so excited. Thank you for that advice. There was definitely a point where I thought, my poor little straw structure just was too weak for that fan and that it was a lost cause. But yeah, I was real excited that it stayed on for all 4 experiments, all 4 wind speeds.
Yeah, I guess that's it, right? When you're doing a project or anything like this where you're building something, you want to play around with it and see what effects have on the structure depending on what you do to it. Obviously the carpet helped in a positive way. Yeah, and so as you can see that the lateral force from the wind was much better. The structure actually stayed, right?
Now, when you say the lateral force from the wind, what does that mean?
That's the coming straight at it.
Mm-hmm.
Like, that's what caused it to slide. So that makes it push.
Okay.
That makes it push to the side, right? So you were able to fix that problem, but then with having it anchored down with the friction or not sliding, that's when you've got the shear force, which they call it, which is where the wind wants to push, and they call it a moment, which is just ultimately bending, right? So that airflow at the top causes the most moment. That's what makes the building kind of bend, right?
Mm-hmm.
Yeah. So one problem solved, and then a new problem created.
Right. Well, so shear force, that was the things I noticed. I was waiting for the building to fall apart. It never did, at least in the amount of time I let it blow on there. But what recommendations would you have to prevent that shear force in the future?
Right. So I think that's just the next step in our problem solving, right? We got rid of the one problem we had yesterday. Now we see that kind of bending moment. That's where the kind of internal building of the structure, where maybe if you had some cross beams from maybe the base to the top of the opposite corner,
like this.
like diagonal, right? Yeah, any kind. You just play around with it and try and figure out which is the strongest. That would help to cause that top from trying to bend over.
Okay, and I
Right.
felt like, so I did these with duct tape. My joints, are they called joints?
Yeah, I mean different fasteners, whatever you want to call.
Is there something I could have done to reinforce these a little better? I mean, they lasted, but it seemed like they were about to pop at some point.
Yeah, I mean ultimately, if you had a strong enough wind and they failed, then they're not strong enough. But as long as they're still holding the straws or whatever together, that's not going to be the issue, right?
And so I wanted to get your feedback on how I ran the experiment, if you maybe had some advice or guidance how to improve the experiment to make it even more scientific.
I think with science, in any experiment you do, if you're going to change something, you want to keep everything constant and maybe change one of the variables.
Okay.
Like if you're placing it on the rug in a certain spot, make sure it's in the same spot every time. If you're using a certain weight to weigh things down, make sure that it's always constant. And then you maybe, like we said, if there was a third part to this, we have a pretty sound experiment now. If you play around with how you put the cross beams or support to try and keep it from balancing, you can kind of document and see which method works best for solving this next problem we came across.
So okay, that's really great feedback. So one way that I did the feedback right was the only variable I changed was putting the rug down.
Right.
Until that top blew back, and then put the rocks down. But it sounds like one thing I could have done better is just make sure, like maybe that very first time, because I set it down, kind of eyeballed it, said good enough. But maybe I should have measured, okay, I have it set 2 feet back, and then measure for each of the following experiments.
Right. Right. Yeah, exactly. You always want to try and maybe the first time you do thing, document everything so you don't forget how minimal something is that really turns out to be important in the big picture, right? Like that distance the fan is from it, or where it's placed on the carpet, or where the rocks are placed. That can all affect the outcome, you know.
Yeah. Okay. All right. Well, this has been great, Shaun. Thank you so much for coming and talking with us. And before we go, any closing advice you have for the students?
No, just stick to it. I mean, people invent things every day, so just stick with it. Yeah, make sure you take good records and have fun with it. I mean, there's so many different things you can do when you're designing something to try and do the best you can. You know, that's all you can do.
All right. Well, thank you so much. We really appreciate your help. I'm really excited. I know I had a great time, and it was really exciting to make that change and not have the structure blow over. And if I would have tried to solve it on my own, I don't know what I would have done, but it would have been a lot more work than putting a rug down. I'm going to tell you that much. So, and to the kids at home, I want to encourage you to continue to build, experiment, tinker, explore. And one great way to do that is our STEM at CGI building structures lesson, which is what I based this off of. And so if you go to the CGI's website and look at STEM at CGI at home, you'll be able to find that lesson, and it's possible you're already in the lesson and watching this video. And so thanks so much and have a great day, and we can't wait to see what you come up with.